And this is Nathaniel. Today we'll be discussing about software configuration management. In our last lecture, we have been discussing about the object model and the problem modeling technique or domain modeling technique. So today, by extending these concepts of software engineering, we'll dive more on the software configuration management. Specifically, we'll be discussing the definitions of software configuration management, the working scenarios for software configuration management, and we'll see some revision control functions or distributed version control systems like Git and GitHub. So let's start our discussion by raising a question: why do we need software configuration management? So software configuration management in general is a process of controlling the evolution of your software system. It's a set of practices and processes used to systematically manage changes to software products and it's throughout their life cycle. So the main focus of software configuration management is on controlling and tracking software artifacts. When we say software artifacts, it includes source code, documentation, configuration files, and other related components. So the main benefit of software configuration management is, for instance, the first thing is simplifying code sharing and other documents. So if you have a software configuration management platform, then it will be easy for you to share your code without conflict of merge or without any miss of data in general. So the main benefit of such kind of techniques like software configuration management is the first thing, it simplifies sharing code and other documents. Mind you, software configuration management could imply the management of software configurations, but it can also be extended to manage the configuration of other documents in addition to softwares. The other benefit of software configuration management is its ability to revert an older version. So most of the time in file systems, this kind of functionalities are available, but specific to the software configuration management, it provides us the undo capability, even though we are working in a distributed environment. In relation to this one, it also allows coherently integrate contributions from team members. Mind you, most software development projects and the project team is distributed over the network, and two or more teams might have to work on the same component of the software, and this might cause a configuration issue. So for this purpose, specifically, it might cause inconsistency issue. So for that purpose, this software configuration management serves as a base for coherently integrating contributions from the various team members, or it helps us to merge updates on different or geographically distributed nodes without a major merge conflict. So it also helps us to notify interested parties about new modifications, so it has reporting functionalities. The other importance of software configuration management is it enables or it helps us to create audit trail or archiving. So when we say audit trail, it's also known as an audit log or audit history, and it refers to the chronological record of activities or events that have occurred within a system, application, or process. So the main purpose of audit trail is to serve as a detailed and sequential documentation of actions taken and changes made, and also transactions performed within a specific context. Software configuration management system allows us to answer questions like when was the last change on a given software component made, who is responsible for that change. Even we can deal with this per line of code level. What is the difference between the current version and last week's version? This could also be answered if you are using software configuration management tool. How many lines of code did we change in this release in relation to the other release? Which files are changed most frequently? Such kind of very important questions can only be answered if you are using software configuration management tools. So from this perspective, software configuration management is an integral part of software engineers and software engineering. So basically, software configuration management simplifies collaboration and increases productivity. Uh, but when we see it from other perspectives, we can also do this without sophisticated software configuration management tools. We can use, for instance, old-fashioned techniques like email, file system, in order to manage the configuration of different files or documents. But using such old-fashioned systems like email and files has its own problems. The first problem that we might face while working on such kind of old-fashioned systems for version control or configuration management is lack of centralized control. As you know, you cannot have a file system that can serve as a central component or a middleware for multiple users in general. So if you have one file system, then a given file system will have its own dedicated application, and change in your file system does not affect the similar file systems in other node or under other users' control. So for this purpose, email-based or file-based systems can serve as configuration management platforms, but they lack centralized control. So users using such kind of old-file systems cannot control the configuration of their file centrally. So due to this, it also has limited collaboration because users or programmers cannot collaborate simultaneously. So this is also one of the problems that come along with old-fashioned systems for version control. The other most important thing in this perspective is difficulty in tracking changes. So software configuration management tools or version control tools, the main purpose of these tools is enabling change tracking. Okay, but when we come to file systems, there is no way to track changes in a centralized manner. The other one is lack of granularity. This can be described as, for instance, from the software configuration management perspective, you can track changes made on line level per a given class. For instance, in a given class, you might have 100 or 200 or more or less number of lines that constructs or that constitutes the class. So you can control the version of each line in sophisticated software configuration management tools like Git and GitHub. But when you come to old-fashioned systems like email and file system, they lack granularity. That means email and file systems typically do not offer granular version control. And due to this, it may be difficult to track changes at a file level or identify specific modification made within a document or code file. So to summarize this, we might face problems with naming convention. We might also face problems while trying to reconcile different versions which are owned by different person on the same file. So for this reason, old-fashioned systems for version control are not recommended. But as a software engineer, we are always recommended to use good software or like mature software configuration management tools. That being said about software configuration management and the need for software configuration management tools, now let's talk about the definitions of some of the most important concepts in software configuration management. So the first concept is software configuration, basically. So software configuration is a collection of work products or artifacts created during a project lifetime. So software configuration basically refers to the overall management of software artifacts, their associated attributes throughout their life cycle. So it involves tracking, controlling, and organizing various components such as source code, documentation, libraries, configuration files, and data among others. When we come to software configuration item, it's any piece of knowledge. We call it also work product or artifact, created by a person, so that person could be a developer or customer. So it doesn't have to be, a Java file or C++ file or high-level language-based script. It can also be, a diary of your customer. So anything that is created in your software environment and that is in adherence to the requirements of the software project can also be considered as a software configuration item. On the other hand, a snapshot of software configuration or a configuration item is called version of that item at a specific time. So when we say version, it's a snapshot of a software configuration or a configuration item at a specific time. That's an important concept while talking about software configuration management is a commit. So we say something is committed when we submit it to the software configuration project base, or we call it repository. So if you submit something that you have done locally to a central database, a central project database, we call it repository, then what you are doing is called committing. On the other hand, build is another important concept. A build is a version of a program code or part of a software configuration. And it's also a process by which program code is converted into a standalone form that can be run on a computer. So it's very important to compare and contrast between a software configuration and a build. So as we already said, software configuration refers to the overall management of software artifacts and their associated attributes throughout the software development lifecycle. For instance, configuration management also aims to establish and maintain consistency, traceability, and integrity of software configurations. But when we come to build, a build is a process of compiling, linking, packaging the source code and related files to create a deployable software product or component. So the overall purpose of build is to create executable code that can run and operate on some problem. But when we come to software configuration or software configuration management in general, it includes concepts like tracking, controlling, and organizing of various components. Now, let's see what repository and workspace are. So in a given version control environment, a repository is a shared folder with version control enabled, and a workspace is a private or an individual developer working area. We can consider both of them as a folder with additional functionality called version control, or the ability to track changes in a given folder environment. So the main difference between these two is that project database or repository is a folder which has version control and which is shared among different developers, and it's stored in shared memory. But when you come to workspace is a private working directory for developers, and it's not usually shared between or among developers. Whenever a developer wants to work on some section of the project, then he has to first pull the state of the project database or repository to its local workspace, make modifications, and push back the modifications back to the project database or repository. So from this project database is usually on a remote server, and that server could be mirrored one on several servers. So software configuration management provides a set of tools to interact with both project database, which is shared memory, and also local working space or workspace. The other important concept in version control is version graph and the concept of branching. So in any version control system, if you want to work on some aspect of your code base, you have to create a different snapshot of the code base by using branches, and the creation of different branches in a given repository creates the version graph in general. So as you can see here, the workspace, or it could be the repository, shared memory based code base. It started here at the root level, and various consecutive changes are described as a node. Here we have the first node, for instance. That means this is a place where we have added or altered some contents of the previous root snapshot. So this line in general, we call it a trunk or main line, okay? And whenever a developer wants to take modifications or make modifications on any of these versions of the same trunk in the main line, he may have to fork or copy the current snapshot of that folder or repository to a separate folder which has information about the history of the main branch or trunk. So the process of copying some state of repository is called forking. Even there is a git command called git fork for this purpose. So fork can be done for two main purposes. The first one would be to fix bugs or to perform some modifications on existing main line and merge it back to the main line, which is this case 1, I would say. The second case is forking for product line. That means here the modifications done here are not supposed to be propagated back to the main line. So this is usually used for or used by developers who want to take some state or some snapshots of the main line and use it for producing a slightly different product in the main line or in the product line in general. So in this graph, each graph represents a version of the software configuration shared with the team. So we can think of branches as separate folders, each with its own content and history. So the project snapshot at the tip of the branch represents the latest version. Okay, at the tip represents the latest version of the folder in general. Let's talk about some of the working scenarios using version control systems. So the first scenario that you might use version control systems is to undo your mistakes while working on something new. The second one is to support multi-pronged product evolution. So this multi-pronged product evolution is parallel versions, is a situation where parallel versions exist at times but will eventually merge. So this is, for instance, a good example of multi-pronged product evolution. Okay. The third scenario for using version control systems is to developing product lines. This is a different one because it is a description for a situation where coexisting parallel versions, that means the same product for different markets, that will never merge. So here we will have multiple trunks rather than one trunk and a different branch. Okay. And the other one would be a scenario where all developers can push or write to the shared memory. And the last one is a really large project setup where developers are not allowed to merge or push their contents directly to the shared memory, but the configuration management is responsible to mediate this process. Let's see each of these in detail. Look, you might have some version of a document. It could be, by the way, a Word document or Excel sheet or anything. It could be a code, Java code or Python code or any other code. So assume you're working on the file. You started working on the file at 8 a.m. in the morning, and after committing changes that you have made at 8:30, you again start to work on the same file, and from time 8:30 up to say 9, you notice that you have made changes, and those changes are mistakes. So in this case, you have to have some easy mechanisms, to revert back or reset back to the version where it was correct. So for this purpose, we have different mechanisms in version control. In general, their terminology is undoing operations or undo operations. So let's say we have initialized the Git repository here at the root. Here we have the first change committed. Here we have the second change committed, and here we have the third change committed. Let's say this is made at, as I told you, at 8:30. Okay. Let's say this is made at 8:30, and from 8:30 up to 9. From 8:30 up to 9, you have made some wrong things. Okay, so in order to undo these operations from here to here, you have to use version control operations. There are two major operations. The first one is revert and the second one is reset. So here, for instance, this is an undo operation that completely cancels the history and the snapshot that is created after C2, which is after 8:30 a.m. in the morning. So this is called resetting. Okay. The other operation is called reverting. Reverting performs undoing by preserving the history. That means after C3, it will put C2. So the current tip of the main line or the trunk will be C2, and C3 will be the previous version or snapshot of the main line. So in this case, what we get when we try to access the repository or the folder is C2. So this is again undoing, from here we are undoing to here, but if you want to access again C3, this will give you a good opportunity or possibility. So this is called a safe undo operation, which is called reverting, and the previous one that we see here that deletes history is called unsafe one. So we can undo commit, we can undo merge, or we can undo even a checkout, okay? So we'll see details of the undo operations later in this chapter. The other scenario for using version control systems is multi-pronged product evolution, which is multiple branches eventually merging to a single node in the main line. So in this way, parallel versions coexist at times, but will eventually merge as we already said. So if you can see here, for instance, C4 is forked from here C1. We do have C2, we have C3. From C3, we have forked C7 and C6, but all eventually merges to the main trunk, or the main line. This is one scenario. The other scenario that we have seen is working with peers, where all developers can directly push to the central repository. In this scenario, it's better to see two slight differences of writing to the central repository. The first one is seen by developer 1's scenario, and the second one will be seen by the developer B's scenario. Look, here we have a current snapshot of your repository, which is shared one, and assume we do have two developers, developer A and B. So as you can see here, developer A, this one, okay, forks from the current snapshot of the repository, which is shared workspace, and checks out to the current state and make change. This is modification. And before anyone else in this environment, because we do have two users, before developer B, he check-ins or she check-ins. So that means he's asking for pull request. That means he's asking for his changes to be propagated to the main line. Then in this case, his request will be accepted because there is no one operating on the same folder at a time who requested pull or who requested merge to the main line. So in this case, developer 1's request will be accepted, okay? But when you see developer B or developer 2, both developer A and developer B, they took the same snapshot of the central repository, but in the meantime, developer A was able to make changes and merge them back to a new version of the repository in the main line. But using developer B, using the earliest version of the central repository, he makes change and asks for pull request here. This request will not be accepted by the version control system, and this is mainly due to the earlier changes made by the developer 1, which are not considered by developer B. So for this purpose, the version control rejects it and requests the developer 2 or developer B to merge his modifications with the one made by developer A, because first come first served is the principle here. Then after merging the changes made by developer B can ask for check-in, pull request, and it will be accepted. This is how in a centralized workflow, two developers who have access to push directly to the central repository operate in synchronized manner. The other one is usually for larger size projects, where there is a configuration manager responsible to inspect pull requests or merge requests and merge the code. So here we have a project repository. Look, and the configuration manager is responsible to manage the project repository. As we already defined, project repository is a shared one, shared folder with version control level. So in this environment, we do have, again, multiple developers. The developers might even have their own public repository, okay? And further, a single developer might have his or her own workspace, which is forked from or cloned from the developer's public repository, or even the project repository in general. So here, the configuration manager is responsible to push to a project repository. So any change made by the developers will be pushed by the the configuration manager to the project repository at first time. Then assume we do have developers who pulled from the project repository here. Okay, so they might pull using different workspaces or even the same shared developers repository. They make changes, modifications, and they push back to the developers repository, which is here. And they raise pull requests. That is how they operate, how we operate in general, version control system. First, you pull from the project repository, you make changes collectively or by individually at workspace level, and you push back to the developer's public repository. And after the pushing back to the developer's public repository, from here to here, you have to raise pull requests or merge requests. And the guy who is responsible to merge these requests back to the project repository is called configuration manager. So these requests might be accepted or rejected depending on many conditions. If there is a conflict of merge conflict, for instance, it might be rejected, and the developer public repository or the guy who is submitting in representing the developers will be notified to request will be notified, and revision and resubmission will be requested, as you can see here. If the pull request is accepted, configuration manager will merge what is merged in the developers repository to the project repository here. So here there is one important concept. For instance, here you have a public repository here and also another mega public repository here. So the flow of control here shows you that the developer, a single developer, can raise pull request to the developer's public repository and again consecutively to the project repository. So first, if the developer managed to get his modifications merged to the developer's repository, then it will be consecutively or transitively merged to the project repository, which is the grand public repository. So when we see the scenario when pull requests are rejected, here the developer is responsible to revise it and push back to the developer's repository and raise pull requests so that it will be pushed to the project repository. So this is the well-known scenario while using version control systems in larger size projects. These are some of the commands that you can use while working on version control systems, especially Git. As you can see here, we do have developers local repository. Here we have another team member's local repository, and here we have a repository which is shared among developers. So any developer who intends to work on a shared repository first has to pull, okay, or pull means copy the current content of the public repository to its to his local folder. And whenever changes are made here in its local workspace, then it can be pushed back to the central repository, as you can see here. So the process of copying, okay, the process of copying a central repository, shared repository, to a local repository for the first time is called cloning, as you can see here. You can use git clone and the URL of the clone or the URL or the clone address of the shared repository. Then once you copied the contents of the shared repository, then you can make changes and push back to the main repository, central repository. And again, whenever changes are made by other developers, as you can see here, to the shared repository, and if your local repository is not in sync with or updated in relation to the central repositories, then you can raise pull requests where changes in the central server will be pulled back to and propagated to your local repository. Next, I'll show you details of some of the commands that we use while working on GitHub or Git to control versions. Then right after that, I will talk about important concepts in this version control chapter. Before discussing about the commands that Git operates on, I think it's better first to create a Git repository, a public repository. So what you are seeing now is my GitHub page. From here, I will create a shared public repository. So I click new, and inside my account, I will create, let's say, SING 2023. Let's say that's my repository. And inside here, this is just for academic purpose, would be its description. I let it to be public, and I will add README file. So this repository will be a public repository that has a README file. So details you can configure here, you know, git ignore, adding git ignore, or choosing license. There are different types of licenses, as you can see here: Apache license, GNU General Public License, MIT license, BSD 2.3. So you can choose depending on your requirement, but for now, for this requirement, this would be enough. Then I will create the repository now. So as you can see here, I have created a repository and that has only a README file. The README file includes the project or the repository description. So here I'm going to operate or I'm going to impose some Git commands so that we can learn how we can operate with such kind of version control management systems. The first task would be to clone what you have in the shared repository to your local repository, or we call it workspace. So for that, you'll go to your public repository or anyone else's public repository. Here we have created a repository called SING 2023. Click on the code side and try to get the clone address from here. Okay, here we have, for instance, an HTTP clone address. So for that, I will copy this one here. This is one of the ways, by the way. You can also download zip file, or you can even open it with GitHub desktop if you have the desktop version of GitHub application on your machine. But for now, I will click on the git clone address here, which is an HTTP address. Then I'll go to the terminal, your terminal. By the way, here you should have Git installed on your machine. For that, I will recommend you to read some materials that lets you install Git on your local machine, whether it is Windows or Linux or Mac. There are plenty of references for that. So the first thing would be here to use the git clone command that lets you clone or download public repositories to your local machine. So that lets you, this command lets you download public repositories, or in general repositories, into your workspaces. So for that we say git clone. Okay, then you paste the clone address that you copied a couple of minutes ago. So then hit enter. Here we are just cloning or downloading the SING 2023 because we have used its clone address here. Mind you, the clone address postfix is .git, so we are downloading the all public repository to our workspace. So to see what's inside, you can simply move to that file, SING 2023. You know, if you ls, you see there is one README file. So this is how you can download your public repository to your workspace, which is private developers repository. Okay, we just cloned our public repository to our workspace. Now let's see what we can do with the cloned repository. So we just moved to the repository, which is version control enabled workspace, which is SING 2023. So one of the most important things in version control enabled folders or workspaces is the concept of branch. So branch holds a snapshot of a given modification on a workspace. So if you have, for instance, one workspace and two more branch, then this branch each holds a different version of the software with common similarity in the past. Okay, so in order to see the types and numbers of branches that your workspace hosts, you can use the command git branch simply like this. So it shows you the local uh, branches that you have in your workspace. If you need some more information along with your branch name, like commit message or related information, you use verbose like this, git branch, then minus v. This shows you details of each branch you have at your workspace. If you want branches related to this local workspace but in the remote public repository, you can also use git branch all command. Then this shows you both the branch in the local workspace or all other branches which this local workspace belongs to in the remote workspace or public directory. Here is a command to create new branch or a new snapshot of your current workspace. For that, you use git branch as a command followed by the name of the new branch you want to create. Let's say I want to create a branch called branch2. So when I issue this command, git branch branch2, it will create a new branch called branch2. So look, this asterisk shows where I am currently. I am in the branch called main now, but I have created branch2. That means branch2 has the current snapshot of main command, or the snapshot of main command during the creation process, or the status of main command at the creation of a new branch called branch2 will be automatically copied to the new branch branch2. So this next step would be to shift or to switch to the new branch if you want. For instance, if you want to separately work or make modifications on the new branch, you simply use git checkout and the branch name to switch your current folder to the new folder called branch2. So it's not basically folder, it's branch inside one folder. So we are simply versioning the folder or the workspace by different branches, where each branch contains a different snapshot of the workspace. So if you check now where you are by using git branch, you find out that branch2 is where you are currently. So here now we are in branch 2, and let's modify some contents of this branch 2. So we have a readme file here. Okay, for instance, if I ls here, I will be able to see readme file. So for that purpose, let's modify the readme file here. Okay, I use nano editor since it is very simple. Then nano readme. Here we have the default content of the readme file. Now I want to add a new content from branch 2. Okay, now we have modified content inside branch 2. So if we again check where we are inside branch 2. Then the other command that we want while trying to check the status of our branch or separate snapshot of our workspace is called git status. Okay, git status basically shows you what is not staged for commit or what is not ready for write up to the central or developers repository, which is local to your machine. So here we have, for instance, readme file. Readme file is modified. That's why it's written in red. So it shows you need to add this one to the staging area so that next you will be able to commit it or write it in a persistent manner. Already mentioned, we have a branch 2, which is created now, and we have modified it because we tried to check it with git status. It shows readme file is modified but not staged. What does it mean? So if you modify some contents in your version controlled workspace but not commit the changes to the main directory or the branch that you are working on, then it shows you as modified but not committed. So in order to commit it, first you have to stage it to the commit area. For that we use git add the file name. Okay, this command, git add command, helps you to stage any modified files to the committing area. So if you check again the status of this branch, it's staged now because it's in light green. So it means we are now ready to commit this content or modification to the branch to main directory. In order to do that, we use a command git commit -a like this. It opens an editor called Vim, and this helps you to write the commit information in Vim. In order to write something new, you have to put the mode of this editor into insert mode. For that, I click on I, and I write like first commit in git history like this. Okay. Then I escape to escape out of the insert mode, and I click on command WQ and enter to save and exit. So when I check now, look, sorry, my keyboard has some issues. When I check now with git status, it says there is nothing to commit. So what does it mean? I have successfully committed what I have modified on my branch. So if I open nano readme now, being at branch 2, look, here you see the new content modified. Okay, here we see the new content modified. Okay, so now let's check out to the main branch called main. Okay, then let me clear for clarity. Then git status here. So actually, I haven't successfully checked out to the main branch. Now I have checked out to the main branch. Now let's check the status of this branch. So there is nothing to commit in this branch, but now let's check the content of the readme. Okay, the content of this readme file doesn't have any update since it is a new branch. But as you remember, if you check out to the branch 2 and check the content of readme, you see a new content here. So this is basically the essence of version control. We know branch 2 has new information, new data, or content modifications, but the main branch does not have such kind of information. So it's a little bit outdated in relation to branch 2. Also, the remote repository that you see here inside my account does not have the change that we made for branch 2. So here, what I want you to do is to push what you have done in branch 2 to a new branch in the remote repository. For that, you have to be first in the branch 2, and you simply do git push. This is an important command to push your updates from local branch or workspace to the public repository. So you basically do git push origin. This is a reference to your remote repository, and a branch name. Your branch name, for instance, is branch 2. You can give any other name, by the way. So this one asks for username and then after that password. So you have to provide username and password. By the way, in the password section, you might have to add personal tokens that GitHub generated for you. You might have to paste them here rather than passwords for better security. Then once you hit the enter button on your keyboard, then the contents of your local branch will be pushed to your remote repository. I successfully entered my username and password and then pushed the local branch 2 to the remote branch. So here you see success information or message here. Data is changed. A new branch called branch 2 is pushed to the remote branch or repository branch called branch 2, and the push address is sin2023.git. So let's go back to the main repository which we have created a couple of minutes ago, and let's see what it has. So here, for instance, in the core section, when you click on the branch list, we have the new branch called branch 2. If you click on it and check for the content, we have the new content propagated, which is a new content from branch 2 is propagated. But if you go back to the main branch, the original branch, we have not pushed anything to the main branch, so the main content will be the original one, or the readme content will be the original one. So this is how we can push from local repositories, changes from local repositories to remote repositories per branch level or even per repository level. What we just saw is some of the commands important for version control in Git. I've used the shared repository using the GitHub cloud platform, and locally I used Git to manipulate my workspace locally. So to summarize what we have seen there, first let's start with the states of software configuration items. So generally, there are two major states of software configuration items. The first one is untracked, and the second one is tracked one. So untracked files cannot be considered as configuration items because they are not part of the version control box, or they are not part of the version control environment. So untracked files are files in the developer's working directory, okay? But tracked files are files in the developer's local repository or workspace. So when we see the tracked files could be in unmodified state or modified state or staged state. So unmodified files are those whose latest modifications are committed to the repository, to the local repository. We call them unmodified. That doesn't mean this has not been modified in the previous, but it means all modifications are propagated to the local repository. Modified files are files that are edited, that are modified, but that are not staged or are not even ready for commit or for write-up. We call them modified files. And the other ones are staged files. Staged files are files ready to be committed or written to the local repository history. So in order to, add unmodified files, or sorry, in order to add modified files to the stage where after you can commit them or write them back to the local repository, we use the command called git add. You remember this one from our previous lab session, right? So once you issue git add some file name, then we have seen this will be staged and is ready for commit, right? So in order to commit this one and change the state of the file to unmodified, you simply issue git commit command. In addition to this one, we have seen different commands like git branch, git checkout, git status, git pull, git push are all seen in our previous discussion in this session. That being said about the states of software configuration item and the summary of the commands that we have used for Git management or version management. Now let's again revise the concepts that we have discussed before, which are undoing mistakes. So I already discussed this one. We have two major options. The first one is reverting and the second one is resetting, okay? Then reverting means undoing some mistakes or some change by preserving the history, okay? So if you can see here, for instance, C0 is the first initial, C1 is second modification, and C2 is the third one. So the tip is the head. That means the latest version of the repository is C2 at this time. But if you feel C2 is wrong, then you can undo it. And the first option is reverting. To revert means to to revert or to reposition the position of the head to the previous version while keeping the history. Okay, C2 will be there. Whenever you want to go back to C2, it's possible according to reverting because it will not cancel the history. Okay, it will not cancel the history. It will preserve the history, but tries to reposition the head or the tip of the repository. But the opposite is true in the case of resetting. The same is true here. C0, C1, C2 is the scenario. The head is C2. If you feel C2 is wrong, and if you want to cancel everything about C2, including its history, you can issue git reset command, which is called resetting, that will not preserve the history after C1. So it will completely cancel the history and also the node or the tip of the main line. So we use git revert and git reset for this one. Git reset is the unsafe one, and git revert is the safest undoing mechanism. The other important concept here is rebasing branch. Rebasing is moving a branch to a different baseline commit. In a way, it appears as if it is forked off from a different version. So all commits in the branch are replayed on the new base, as you can see here in the second diagram. I recommend you to read more about version control systems, specifically on Git. There are different manuals written for Git and in general for version control systems. I recommend you to read about this one in detail um, before our lab session. So we'll have a laboratory session, a practical session about version control systems. We will be using Git. Both shared repositories and local workspaces will be used. So up to, until then, I think I recommend you to read and practice on some manuals that you can find online. It's enough for today. Thank you.